Assalamualaikum warahmatullahi wabarakatuh and a very good evening. So today we're going to present about the talk that we had by IRTS Mohd Ikhmil, Fadzrizan by Mohd Hanif. So first of all, I'm going to introduce our panels first. Me, Muhammad Rizwan, is the moderator for the talk. The first panel will be Ashraf Farhan for the agenda A. For agenda B will be Muhammad HAZIQ. And lastly, for agenda C is DJUEMYLLA and also HARIZ. So first of all, I'm going to present about the profile of Mohd Ikhmil Fadzrizan bin Mohd Hanif. IRTS Mohd Ikhmil Fadzrizan Mohd Hanif is a professional engineer with the Board of the Engineers Malaysia (BEM) and a professional technologist with Malaysia Board of Technologies. He is also a corporate member of Institution of Engineers Malaysia and Institution of Engineering and Technology UK. IRTS Ikhmil holds Bachelor of Electrical Engineering in Control, Instrumentation and Automation and Master of Science in Instrumentation and Control Engineering. He has more than 15 years of working experience in instrumentation and control engineering in oil, gas and petrochemical industry and also working experiences as senior lecturer in Institution of Higher Learning Education major in Electrical and Electronics Engineering. His current position as Senior Engineering ICSS, Instrument and Telecommunication at Bumi Armada Berhad, and responsible on operational and asset integrity activities of Bumi Armada Berhad assets at UK, Angola, Indonesia, India, and Vietnam. So moving on to agenda A, I'm going to pass the mic to Ashraf Farhan to continue with this presentation.
Okay, thank you to our moderator, Muhammad RIDZWAN. Assalamualaikum and good evening for everyone. I am Ashraf bin SAFIEE and known as Panel 1 for this forum. So let's discuss about the engineer talk that has been presented by IRTS Mohd Ikhmil Fadzrizan before this. Okay, based on this section, the speaker has explained that there are 4 types of offshore life, which is floating producer storage offloading, central processing platform, drilling rig, and barge. Next. So first I will explain in detail about the scope of work went through by the speaker. So what is FPSO? FPSO means floating production storage offloading and FLNG means floating liquid natural gas. Their working hours is 24 hours operation, divided into 2 shifts. Both is 12 hours, which is 6 AM to 6 PM and 6 PM to 6 AM. Next, it also prepares 6 time meals per day, which is breakfast, lunch, dinner, supper and tea break every 3 hours. Then work at FPSO, it have a offshore rotation for regular crew, production and maintenance. Crew is 40 days work and 40 days off. The best thing is recreational and entertainment. They get Wi-Fi, table tennis, pool, snooker table, even PlayStation or Xbox games, futsal court, gaming studio, gymnasium, cinema and also swimming pool. Next. Next is about central processing platform or called as CPP. So CPP is a place oil and gas condensate processing platform located in the middle of the sea. Their working hours is 24 hours operation also, divided into 2 shifts. What is 12 hours, which is 6 AM to 6 PM and 6 PM to 6 AM. Actually, it have a similarities work at FPSO, which is prepare 6 time meals per day. It have offshore rotation for 40 days works and 40 days off. And also some recreational and entertainment like FPSO. Next. Next is drilling rig. So drilling rig is drilling or work over and wireline activities. Their working hours is also same like a FPSO and CPP, which is 24 hours operation and have 2 shift work time. It also prepares 6 meals per day, but when working at drilling rig section, it have a offshore rotation for 28 days work and 28 days off. The recreational and entertainment for drilling rig section just provide Wi-Fi, pools, snooker table, gym and TV only. Next. Lastly, for the batch, they get to work for pipe laying, geosurvey, exploration, accommodation batch, ship tanker, cargo tanker. Their working hours is also 24 hours operation divided into 2 shifts. It also prepares 6 meals per day, but when working at batch section, it have offshore rotation for 28 days works and 28 days off, or 6 weekdays works and 6 weeks of day, or 3 months works and 1 month off, or 6 months works and 3 months off. The recreational and entertainment for drilling rig section just provide gym and TV only. Okay.
So thank you so much, Ashraf, for giving your talk. So we have learned that how offshore life is and how it provides 6 meals per day for every types of offshore life works. So next, we're going to move on with our second panel, which is Mohd HAZIQ for Agenda B.
Okay, yes. Agenda B is, as you see, is carried as an instrument and control engineer. Next. And in this section, I will explain based on the talk about the section that you can have in this in the career of instrument and control engineer. Next. So this is the operation and maintenance. So what you see here, based on the slide that the talk provide, this is the operation and maintenance scope of work. As you can see, you have to prevent the maintenance, you have to maintenance the plant, spare parts management. So basically, the challenges of operation and maintenance when you want to apply for operation and maintenance work, you have to know the corrective and the troubleshooting of the system machine. And when you do it, you have to do it during live platform or when production. We have to know that. And then it comply also HAC and standard of follow work protection, follow work procedure for safety. You also have to wear PPE, which means personal protective equipment. You can see there, there's a lot of operation maintenance in a lot of factories that you can apply for. Next. So the next one is the design engineering. So when you want to design or engineer on a certain project, propose a certain project, first you have to design. And when you do design, you have to comply with the standard from the company. And the information are specification and architecture and control system values. We have to know the purpose of certain values and the flow of valve sizing for the designing and engineering. You also have to know the piping and the instrumentation diagram, and it led to the challenges that understand the requirement of the project and have to follow the standard when design the project. That is the challenges when you are assigned to the design and engineering in the instrumentation and control engineer. Next. So after you design for a project, the next section is the construction and the project fabrication. As you can see, the construction of fabrication is a project management team. Usually it is for plan and monitor progress on construction and installation activities. So there's few challenges for construction and fabrication, which is one is to meet the deadline for project installation. So when you want to construct, you have to meet a certain deadline. if you don't meet the deadline, that will affect your performance in this section. Yeah, you have to have a good communication skill or leader skill, because you have to manage the contractor and your subcontractor when you do this construction. Next. So the next one is the commissioning and the startup, which is quite important for any project when you want to do a project. So usually a commissioning and startup is we test to function all the new field instrument and control system at the plant. You control the PLC, the shutdown valve, the temperature transmitter, the flow and the level of the water flow maybe. And we have to test the logic programming of ICSS as per drawing and design document. So the challenges of for commissioning and startup, it has to understand the whole process of the facility. So you have so when you do the logic programming, you know how to do it. And you need to know to do a paperwork for startup and provide procedure for the machine if you want to create something. Before you will test, so you will have to do the work procedure. Next. So the last one is a system integrator and fabricator. So system integrator and fabricator is the company who design and fabricate perform logic programming for the control system. The engineer from system integrator will perform the commissioning and functional test or service job for the system and field instrument at the client's facility, such as offshore platform or onshore platform. So the system integrator usually provide equipment and logic programming for control system and must have high technical skills and knowledge on the system and on the equipment, because they're the one that make the PLC or make the emergency shutdown system. They have to know the in and outs of the technical, so they can design and do the integrate the system. Normally the position is project engineer or system engineer or field service engineer. Okay, that's all for the section or phase in the carrier and in the control and instrumentation engineer. I send it back to the moderator. Thank you.
So thank you so much, HAZIQ, for your wonderful points about the operation and maintenance, or even the scope of the job and the skills and requirements needed to perform the task. So moving on to our last agenda, which is agenda C, I'm going to pass the mic to both of our panels, JUEMYLLA and also HARIZ.
Okay, Assalamualaikum, and I will be discuss about the distribute control system. Next. Okay, this distribute control systems is a platform for automated control and operation of a plant or industrial process. So this DCS also combines the following into a single automated system: human-machine interface, logic solver, historian, common database, and alarm management, and also a common engineering suite. So it is also known as integrated control and safety systems, which is in short form is ICSS, and it can also refer to a large scale of I/O up to 100,000 I/O, and then it will present by the Petronas Rapid, which is a Shell Gumusut Kaka platform. Next. Okay, this is the example of IR Ikhmil showed to us last time. So this is the design of the system architecture. So basically, it's just like a example that he explained to us in a basic way. Okay, next. Okay, this is another example also, but in a sketch diagram where how the central control room operated and how does it design properly. So next. Okay, DCS component. So DCS component basically consists of five components. So the first one is the controller, which is CPU or main processor, and inside that it has a process, communications, control, response as per logic, program, and redundancy. So the second type is I/O module. So inside the I/O module, it contains of input and output signal and analog and digital, and also the channels per module, which are in scale of 8, 16, and 32. So the last one is the hybrid universal I/O module. Okay, the third component is the communications module, which is Modbus protocol. So the fourth of components is engineering workstations, which is engineer station, configure logic system, and download program. So the fifth one, the last one for the component is the operator control station, which is HMI, human machine interface, and it consists of operation control plan process. Next. Okay, so CPU processor module. So inside this processor module, it consists of two main types, so which is the CPU main processor, and another one is redundancy, which is backup. Okay, I/O module. I/O module, there are four types of I/O module, which is the first one is the analog input, and inside the analog input, it consists of pressure, floor, level, temperature, and temperature transmitter. So second type is analog output, which consists of control valve and heater. The third one is the digital input, which consists of push button, limit, and switches. So the fourth one is the digital output, which consists of solenoid valve, start, stop motor, and pumps. Okay, this is an example of diagram of traditional I/O modules. So it consists of junction box, there are three junction boxes, and then got one big junction boxes, and then got the marshalling cabinet and the safety managers. Okay, this is the diagram for the universal I/O module. So it consists of RIO field mounted, which consists of the non-hazardous box, some kind like that, and a safety manager. Thanks. Okay, engineering workstation and HMI. So this HMI, they consist of two types. So the first one is the engineering workstation, and I will also explain about the operator station or human machine interface, which is HMI. Okay, communication module. So this communication module, it used to communicate with other DCS system or PLC using Modbus protocol. Example like Yokogawa DCS, Emerson DCS, or Allen Bradley PLC. Next. Okay, what about the Modbus communication? So Modbus communication consists of the Allen Bradley Control Logic PLC, which they use MV156E MNETR, and also consists of DCS system and PLC Modicon and PLC Omron. Next. Okay, for the instrument signal, there consists of three types. So the first one is the analog transmitter. So the analog transmitter, it uses current for about like 4 to 20 mA, and the voltage is around 0 to 10 volts. So for the second one is the process instrument air. So they use the phonetic signal, which is 0.2 to 1 bar, and the third one is the digital binary 0 or 2. So they use the limit switch, which is the mechanical or proximity. And the second one is they use the contact, which is open or closed relay, which is on or off. Next. Okay, for the block diagram of process controller. First, they use the instrument measurement, and then they will go into the control system, which is DCS and PLC, and it will go to the operator console, which is operation, which it monitor the operator console, and then after that it will go to the process plant, which inside the process plant it will monitor the plant and the process of the plant itself go into the instrument measure. And then another type is They will go through the DCS or PLC and straight go to the final control element, which is a valve, and then they will straight go to the process plant and going back to the instrument measurement. Okay, my friend will discuss the next topic. Thank you.
I will continue about field instrumentation in process industries. For instrumentation, the equipment used for measurement, monitoring, and control the process plant. There are three instrument measurement, which is temperature, pressure, level, flow, and valve. Okay. Next is piping and instrumentation diagram. Detailed diagram in the process industry which shows the piping and vessel in the process flow together with the instrumentation and control device. Okay, this is the diagram for piping. It's a diagram for piping. Next. Okay, next is temperature transmitter. There are 4 points here, which is measure the temperature on the process, remote and direct mounted type, thermocouple, high temperature, and RTD, max 1000 degree or 140 degree Celsius. Pressure transmitter. First, measure the pressure inside pipe or vessel. Unit kilo PHG or BARG. Diagram with capillary or tubing type. For the flow transmitter is orifice flow meter, vortex flow meter, turbine flow meter, and Coriolis flow meter. For the level transmitter, it has 4 also, which is differential pressure level transmitter, displacer level transmitter, guided with radar level or non-contract radar level, and float type. For DP level transmitter, we can see this is the closed tank dry leg calculation. Next. Guided with radar level transmitter. This is the diagram for the guided with radar level transmitter. The next is wireless transmitter. And on-off shutdown valve. First, for emergency and isolate process, fail close. Control from DCS or shutdown system, driven by pneumatic instrument air or 24 VDC supply from DCS or SDS to solenoid valve. Last, solenoid valve will open and supply the instrument air to the shutdown valve actuator. Next, blown down valve for emergency and depressurized process line. Second, fail open, control from shutdown system, driven by pneumatic instrument air or 24 volt DC supply from DCS to solenoid valve. And solenoid valve will open and supply the instrument air to the shutdown valve actuator. Control valve. First, pressure control valve or temperature control valve or flow control valve and level control valve. Control from DCS, driven by pneumatic instrument air. DCS supply 4 to 20 mA to IP converters. Positional will control the instrument air supply to control the valve opening and closing. Fail open or fail close.
Okay, thank you so much to all of our panelists for their amazing talk and wonderful points. So to summarize the presentation here, we have gained a lot of beneficial knowledges which can be implemented in the future, and the slide here has provided a lot of insights on what it's like to work in an offshore life and how we can apply the skills that we have or learn the new skills that we need to learn to be used in the offshore life in the work in the future. So thank you so much to everyone for participating in our presentation today. Thank you and have a good day.